Thanks everyone for joining this episode of our webinar series on best practices in e-discovery. Today's session is focused on helping the boutique firm understand the best practices unlocking evidence with forensic collections. My name's Jeff Fugit. I head up sales and marketing for Lexpe, and I'll be the moderator for today's event. We're fortunate because unlike a lot of big law firms that don't have a mature IT strategy for remote connected legal teams, since we're cloud-based, our customers are able to access Lexpe from virtually any internet-connected device. We're fully operational in helping our clients sustain their billable hours and productivity during this pandemic. We've got a lot of information to cover, so I'll get through the introductions quickly. Our webinars take place monthly and cover a variety of relevant e-discovery topics, trends, best practices, and strategies. Our webinars are popular and we have limited seating, so be sure to register promptly for the sessions that are of interest to you. If you have technical issues or questions, please email us at webinars@lexpe.com and we'll address those right away. Our webinars are available online at lexpe.com for viewing via streaming video or downloadable as a PDF presentation or MP3 podcast. You'll find this webinar and a complete listing of other webinars at lexpe.com. To be notified of future live and on-demand events, please email us at webinars@lexpe.com or follow us on LinkedIn. So a little bit about Lexpe. We're based in Austin, Texas, and we provide a very affordable cloud-based e-discovery platform and services. We specialize in equipping organizations and law firms with an e-discovery solution that gives you full control over the e-discovery process, DIY capabilities, and incredibly fast performance. We have the industry's most affordable and full-featured DIY cloud-based e-discovery solution. We're the industry's fastest e-discovery processing and document review platform. We deliver the industry's fastest return on investment per a couple of studies that have been done by G2 Crowd. We've got a team of experienced e-discovery specialists and expert consultants who are all ACED certified and ready to assist on a moment's notice should you need it. If you'd like a demonstration of our platform, simply email us at sales@lexpe.com and we'll get that scheduled for you. Our guest speaker today is Nick Marrero. He is the leading digital forensics examiner at Lexpe. He has extensive digital forensic experience and education ranging from computer to mobile device forensics, as well as vast experience with evidence handling, client-facing, project management, and as a team lead. Prior to Lexpe, Nick was a Discovery Senior Associate at Deloitte for almost 10 years. He has a Bachelor of Science in Computer Forensics from Bloomsburg University of Pennsylvania and is a certified Cellebrite operator and physical analyst. Before I turn it over to Nick, I'm going to cover some of the shifting landscape of electronically stored information, or ESI. The shifting ESI landscape creates challenges and questions regarding preservation, collections, and discoverability. So let's start with mobile devices. While mobile devices are continuing to slowly grow in market penetration because they are nearing a saturation point in the United States, mobile application downloads are experiencing rapid growth. So on this chart from our friends at Cisco Systems, you can see that in 2023, mobile app downloads will almost reach 300 billion. And a lot of those apps have messaging capabilities. Therefore, it's very important to be able to identify the apps deployed on mobile devices. And I'll talk more about this shortly, and I think Nick will cover some of this during his portion of today's session. So as you can see on this slide, there's been a massive uptick in business app downloads to mobile devices since the pandemic hit. So more evidentiary data is residing on mobile devices, and understanding the makeup, character, and quality of the custodians is essential to understanding their propensity to store critical data on their device. So here are some considerations regarding mobile devices. Devices that are corporate owned and under the control of the enterprise are considered discoverable in most cases, as well as personally owned mobile devices participating in a BYOD program, and that's Bring Your Own Device program. In H.J. Heinz versus Star Surplus, it was ruled that with regard to Heinz data present on an employee-owned personal mobile device under its BYOD program, that Heinz has custody and control of Heinz's data, and discovery was permitted to the extent that any of these employees sent or received text messages that were relevant to the case. With personally owned devices, you've got some challenges to contend with. Personal and corporate data can often be commingled on the device. The employee can delete data or port data. If there's forensic evidence that messages were deleted or ported, you might be able to recover them sometimes from the wireless carrier account. Then you've got to contend with shadow IT. So shadow IT is non-corporate sanctioned apps and services that an employee can bring into the enterprise on their own personal mobile device. They can connect that mobile device to a corporate network. They can attach that mobile device to a corporate computer. And when you consider that the iPhone 12 on the previous slide starts with 128 gigs of storage, you've got a highly portable and powerful handheld device that can move just a ton of data. So if an employee had Dropbox installed on their mobile device, as an example, they can easily move corporate files into the cloud. Data portability has never been easier. Most smartphones are also rich sources of location-based data, and that could come into play with your particular matter. In addition, most smartphones have advanced encryption, which can cause challenges from time to time, especially if the custodian's not cooperative. And while most social media apps have robust messaging capabilities, you'll likely need to prove the relevance of social media to your matter if you're seeking unfettered access. And lastly, ephemeral messaging apps cause an interesting challenge, and I'm going to go into more detail on that next. So Wickr, Telegram, Facebook Messenger, and Snapchat are the most common ephemeral messaging apps. So what does that mean? Well, with these apps, you can send a message that will self-destruct after a designated amount of time. So this came up in Waymo versus Uber, where Waymo alleged that Uber misappropriated trade secrets for autonomous vehicles. So during discovery, Waymo argued that Uber used Telegram and Wickr to delete key discoverable information about how they illegally acquired their trade secrets. The judge ruled that while Uber's actions were not intentional, both parties could present evidence on this issue to the jury. So Waymo could offer evidence illustrating that using these ephemeral messaging applications created gaps in their case, since the apps deleted the communications that would have filled the case gaps. So it's important to be able to understand what the app landscape looks like on these mobile devices, and that could absolutely factor into your matter. All right, we're continuing to see strong growth in non-email ESI evidence from the following messaging, collaboration, and social media platforms. You should become well-versed with the demographics of the users of these platforms because they're often rich sources of evidentiary ESI. And so understanding if the custodians in your matter fit the profile of the users or if they have these applications deployed on their devices is really important. I'm not going to spend too much time on the next two slides other than to point out how the huge shift in app adoption due to the COVID pandemic has certainly changed the ESI landscape. And this will likely have very, very long-term ramifications. So as you can see, the huge uptick in the use of certain apps. So you've got Zoom, Palo Alto Networks, Global Protect product, and you've got Cisco's AnyConnect product as well, seeing big upticks in utilization. And then on this next slide, you can see the massive growth in Zoom and the other products as well mentioned here. And that's been well covered in the media as well. So with that, I'd like to ask our first polling question before we transition this over to Nick. Our first polling question is, how many document-intensive cases do you handle each year? And while you're answering that question, I'll thank you for participating in our polling questions today. All right, I'll go ahead and close out that polling question. And our next polling question is, are you seeing an increase in demand for forensic collections? We've got a few more answers coming in. All right, I'll go ahead and close out that poll. And without further ado, Nick Marrero. Nick?
Thank you, Jeff, for that introduction. Hello, everyone. My name is Nick Marrero, and I'm the Digital Forensics Examiner with Lexby. Today, I'm going to discuss digital forensics. We're going to look at what exactly digital forensics is, what types of digital media can be collected and examined, as well as important pieces of a forensic collection. We'll take a closer look at different media types, including computers, mobile devices, and cloud data. We'll also discuss forensic best practices and common methodologies. Finally, I'd like to talk about how digital forensics plays a role in e-discovery. Digital forensics is the identification, preservation, recovery, and analysis of digital media. Identification being the understanding of where potential digital information may be located. Preservation being how the devices and data are handled, ensuring nothing is altered and creating a forensically sound copy of that data. Recovery and analysis go hand in hand. While performing an analysis of digital media and data, the recovery of deleted or hidden data can occur. Analysis of that data would be the most time-consuming part of the forensic examiner's role. Depending on what a client is specifically looking for on a piece of digital media and the actual size of that data, the analysis could take a substantial amount of time. A forensic examiner can use forensic tools to perform all of these tasks and identify whatever information could be in question. Data integrity is a very important aspect of a forensic examiner's job. Our main goal is to ensure no data has been changed or altered during our forensic preservation and analysis. We will be discussing a couple ways data integrity is ensured throughout this presentation, including write blockers and hash values. So, what types of data and information can be uncovered during a forensic collection? Some very important pieces of evidence can be found. Sometimes very easily, other times not so much. A big one would be deleted data. Other information that can be uncovered includes what user was logged into a computer when a specific action was performed. We can find out information on the external devices that were plugged into a computer. We can find location data on photos to possibly know where a picture was taken, along with when and by whom. Think you cleared your Google history? A forensic examiner can recover searches even if a user went into the browser and hit that clear all button. Collecting email and chats can be very informative and is a common collection request. There's an abundance of information that can be discovered when investigating digital media. It is incredibly rare these days for an individual to not own a smartphone, computer, or tablet. There are only 2 people I know that don't, and they're my grandparents who are in their 80s, still using their flip phones, and don't even have the internet at their home. I think it's safe to say they are the exception nowadays, with the vast majority of people living their lives on their phones through social media and storing their documents in the cloud. I'd argue it's much easier to find the figurative smoking gun in crimes committed in the digital age. The altering of data can unfortunately be very easy. The good thing about that in the eyes of a forensic examiner is that some type of trace is almost always left. If someone has a photograph on their computer that they want to hide from family, say, they might change the extension of the file from JPEG to something that wouldn't allow the system to open the file since the computer knows something is wrong. In forensics, most tools can perform a signature analysis, which will look at the file's extension and see if it matches the file signature, which is data within a file that identifies and verifies the content of that file. For example, an image file like a JPEG file has a specific file signature in its data. If the signature doesn't match the extension it thinks it should have, the file won't perform its function properly. File signature analysis checks the signature of every file along with the extensions to see if they match. This can help narrow down anything from someone may have tried to alter in order to hide it. Later, we will be discussing hash values, which help identify altered data as well. A digital forensic examiner is trained to identify, preserve, recover, and analyze data in what we call a forensically sound manner. Forensic examiners can ensure the integrity of all data we come across and are able to prove that the data at the end of an investigation is the same data that was handed off to them. I'm sure we've all been watching a cop show like Law and Order and see one of the detectives just hop on a computer in a suspect's house or grab their phone and start swiping around. This does not, or at the very least should not, happen in real life. That data is now possibly altered and can be thrown out of court. Forensic examiners in real life would be called in to secure the device and take the appropriate steps in preserving that data. This brings us to digital forensics best practices. A lot of forensic examiners training and education focus on best practices. We are responsible for possibly the most crucial evidence within some cases. The first thing we need to ensure is that everything gets documented. A chain of custody form should start the second the device is taken into possession. We'll discuss this form in more detail a little later. Photographing devices will provide proof of the condition of the devices when received, as well as help with identification of the device in question. What cords and connectors the device came with should also be recorded. If a computer is turned on when acquired, what was on the screen at the time. Proper evidence handling includes the transfer and storage and general handling of devices. Ensure that the device is handed off to the proper person or party. Having evidence left at a door or even with the front desk person doesn't constitute as a proper handoff. Coordination with the receiving party or the sender is crucial in safeguarding that item from getting into the wrong hands and possibly putting that item at risk of tampering or even having the chain of custody on the device broken or questioned. Sending devices through a carrier can also be an option, as long as tracking numbers are recorded and making sure the package is signed for upon receival. Once a device is at a specific location, say Lexby for example, the device or evidence needs to be properly logged and stored in a secure place. Anytime that device is retrieved or worked on, proper logging will take place, like the chain of custody being updated. Write blockers are very important. Connecting a drive directly to a computer for preservation or analysis is incredibly risky and could alter the data on the device. A write blocker, whether a physical one or a software one, will ensure that the device is read-only. No data can be written to the device when a write blocker is in use, and the contents of the data will remain intact and unaltered. Using one and documenting the use of it certifies the device will not risk alteration. Connecting a piece of evidence without a write blocker can put the whole device in question regarding its validity. Having a write blocker proves that the examiner could not alter any data on the device. A physical write blocking device is one that connects to the device that needs to be write blocked, and then to the examiner's forensic workstation. When the device is turned on, evidence is powered up and the forensic machine now has read-only access to that item. I have personally used Tableau's write blocking devices extensively in the past. Other write blockers are made by CRU, Weebitech, as well as CoolGear. A software version of the write blocker can also be used. The software write blockers can be turned on via the program on the machine, enabling the write blocking feature of devices plugged into the forensic machine. Some examples include SafeBlock, USB write blocker, and SoftBlock, which is specifically for Macs. An important part of the forensic collection is the coordination between the requester and the examiner. The requester can have a very strict deadline or may have certain pins and passcodes the examiner could use. The forensic examiner needs to work with the requester to understand exactly what types of collections or analysis needs to occur. The forensic examiner will also need to clearly communicate what can and can't be done during the examination, get all the details needed to properly conduct the analysis, as well as coordinating the receiving and return of the devices that have been collected. Working together and having a clear line of communication, make sure all parties are aligned and that the best outcome will be provided. When a device, folder, or file is collected, a forensic image is created. Forensic tools take all the contents of the evidence, make a bit-for-bit copy of the data, and store it within a forensic container. The container ensures the collected data cannot be altered in any way. This is what the analysis is actually performed on. The original device or source device should always be imaged if possible. Creating the image gives the forensic examiner an exact copy to work on, keeping the source free from possible alteration, damage, or contamination. Forensic images come in a few different formats, including RAW or DD, EO1, LO1, 81, and SMART. Forensic tools are able to open these image formats in order to view and analyze the data within. Reporting. This is an aspect of digital forensics that is either unnecessary or incredibly important. If the request is to just preserve an email account for legal to review later, then a report is probably not needed. If an actual analysis or investigation is occurring and information from that is needed, then a report is imperative. Reports will include every single aspect of a case, every part of the documentation I spoke about earlier, and all evidence and findings uncovered from the analysis. This information should be as detailed as possible. It's best to have all details, big or small, as part of the forensic report. Finally, the return of devices is important to ensure the device goes back to the correct party and the chain of custody form is closed out. Now to discuss the planning and executing of forensic collections. First is the identification. What needs to be acquired? The coordination between examiner and requester is important in this identification step. A forensic examiner can ask the requester questions about potential other devices or storage methods, making sure that nothing gets missed. In terms of laptops and desktops, there could potentially be an option to collect the device remotely. Some forensic tools provide the means to perform such a collection. This usually involves the examiner deploying an agent to the targeted machine, giving their tool access to the computer. The preservation can then be done remotely as long as the targeted machine stays online. A physical collection would be the device getting into the hands of the examiner, pulling the hard drive, connecting it through write blocker to the forensic machine, and imaging or preserving the device. Both ways have their benefits, but a physical preservation takes much less time. Coordination with the client and the custodian is very important. For the examiner to get access to cloud storage or an email account, credentials are needed. The client or requester will need to coordinate with the owner of the data to ensure the examiner has what they need to access the data properly. This could be in terms of keeping a computer online during a remote collection, providing credentials to a social media platform, or being prepared to provide the two-step verification code needed to access an email account. Again, I'm mentioning chain of custody. The planning and executing needs to have the documentation, and the COC is one of the most important ones. This document should follow the collection or analysis from start to finish. Planning a collection requires a look at your best practices. Make sure everything discussed with the requester is taken into account and ensure the best practices are being applied to every aspect of the collection and investigation. And again, the return of the device is crucial. Most people want their devices returned as soon as possible, especially phones. Others will require some type of storage option for the device. Planning ahead of time ensures the right actions are taken. Now, here's a look at an example of a chain of custody. These forms can be modified in any way to remove or add fields, change any wording, or add a firm's letterhead. There really is no standard, but there is information that's pertinent to a COC. Device details. These include the device's make, model, and serial number. what the type of a device it is, like a phone, a computer, or a hard drive. Also, a detailed description of the appearance of the device, like if there are any stickers or writing on it, or a cracked screen, or any scratches. The bottom section shows the transfer details. There are sections to illustrate the transfer of a device from one party to the next, the reason for that transfer, the names of the parties, and their signatures. Also very important are the dates and times. You can also include any other information on a COC you feel important. Some will have information on the case the device pertains to. Now here's a look at the most common types of devices collected and analyzed. We have computer and hard drive devices, mobile devices, cloud storage, and webmail. Now I'd like to go over types of devices and details about each. Computers and hard drives are lumped together, along with other devices like thumb drives, external hard drives, and optical media like CDs and DVDs, due to their relatively similar way of storing data. These devices all have file systems used for storage and retrieval of data. FAT, or file allocation table, file systems are commonly seen on portable devices. NTFS, or NT file system, was developed by Microsoft and used as the default file system for Windows machines starting around the Windows NT era and is still used today. exFAT was introduced by Microsoft in 2006 and is optimized for flash memory like thumb drives and SD cards. Macs use what's called APFS, or Apple File System. All the file systems have their own ways of managing and storing the data. And when collecting these devices, there are three main ways to do those collections. Those are physical, logical, and targeted. A physical collection is a bit-for-bit collection of the drive, literally everything on that drive. Free space, unallocated space, everything that you stored on it, everything. Logic collections are the scene data, the allocated space of the drive. And targeted collections are of a specific file or folder on the drive, like just the PST files or just the stuff on the desktop or a user profile. It's worth mentioning that recent and current gaming systems use hard drives for storage. There have been cases where gaming devices contain evidence such as chats or secretly hidden data. If there is a hard drive in it, there's a way to store data on it. And there are many forensic tools used to preserve and analyze computers and hard drives, including Magnet's Axiom, OpenText's EnCase, Access Data's FTK, there's Xways, and there's SleuthKit plus Autopsy, which is preferred for Linux machines. Next, we'll look at mobile devices. Mobile devices are everywhere. Within the last decade or so, smartphones have become not only a staple in our society, but even possibly a necessity. There are two major players in the smartphone game, Android and Apple. Android devices make up the majority share of the smartphone market, followed by Apple. There are others out there too, like Windows OS phones and BlackBerry, but they make up such a small amount of the total smartphones and they're not very relevant these days. Forensic tools used for mobile device collections include Axiom, Cellebrite, EnCase, and Oxygen. Collecting from a mobile device is much different than from computers, and some forensic companies like Cellebrite specialize in mobile device forensic collections and analysis. There are a few different types of collections you can perform on a mobile device. Physical collections are every single bit of the mobile device. Logical would be the user data only and not the free space of the phone. File system collection just collects the file system. And the last resort in mobile device collections would be a manual collection. This is often used when a forensic tool can't gain access to a device due to the phone's age or operating system restrictions. A manual collection would be literally going through the phone manually and taking pictures of each screen. Not very efficient, but it's the very last resort. The type of data you can pull from a mobile device includes the following: everything from chats, calendar, notes, location data, email. The list can go on and on of the type of information you can pull from a phone. These here are the most sought after data sets, but there's still a lot more that can be discovered within a phone. Next, the cloud and webmail collections. They can be performed using a couple different methods. Forensic tools like Axiom or Celebrate can collect from a variety of different cloud, webmail, and social media platforms. Some platforms even have their own way of pulling the data, like with Google Takeout, where you can download a copy of Google data stored in the cloud, like emails or chats or the documents you have stored up there. Social media and business communication tools like Slack or Teams can be collected with forensic tools as well. Like with cloud and webmail, credentials to log into the platform are necessary to perform the collections. It's important to verify with the custodian of a collection what type of cloud data they have. These are often the most forgotten storage solutions. There will be times when Apple's iCloud stores data from a phone and the custodian isn't aware of it, since they are either not very tech savvy or they just forget they set it up. In-depth interviews regarding digital media and possibilities of storage locations may be the best method to determining where all the data is stored. Forensic examiners can be beneficial in this area with our knowledge of all the different platforms out there. Next, I would like to talk about hash values. Hash values are a very important part of a forensic investigation. A hash value is a numeric value of a fixed length that uniquely identifies a file. Every file has a hash value. There are a few different types of hashes, like the MD5, the SHA-1, or the SHA-256. Hash values are very integral parts in determining a file's integrity. For example, if a client is looking for a certain digital document that was stolen from their firm, the hash value would match an exact copy of that document on the suspect's computer. Hash values can also be used in determining what system files on a machine can be ignored, since they are known files and won't affect an investigation. Next is metadata. Metadata is data about data. All files have metadata. The information found within the metadata can include the file's name, author, creation, modified, access dates and times. Files will have different types of metadata depending on the file type. Like in this example, a Word document includes information like the author and the subject, whereas an image file wouldn't contain that information since it's not relevant to the file type. Next up is deleted data. Oftentimes, files deleted by the user can still be found and recovered from a device. When file is deleted, the file system is basically seeing that the location that the file was stored in is now free to write to. Since the location may not get written to, the file can be recoverable. Even if a location of a deleted file is partially written over, some of the file can still be seen and pieces may be recoverable. There are caveats with deleted data though, like metadata not always being recoverable with the file. Deleted data on mobile devices can be harder to recover. This is due to the free space of mobile devices being harder to access. Collecting free space from mobile devices isn't always possible, especially on newer phones, due to the operating system's privacy and security restrictions. But tools like Celebrate are always working on ways to pull the most data from every new OS update that comes out. Solid state drives can automatically overwrite deleted file storage locations with zeros, making it much harder to recover any deleted information from a solid state drive. Now on to eDiscovery integration. Data collected by a forensic examiner can be integrated into a review platform. Data can be uploaded in multiple different formats, whether it be the raw files in PDF form or in a spreadsheet. The pro of having an eDiscovery platform for review of forensically collected data is that data goes directly from the source to the platform. There's no emailing or USB transfers of that data from here to there. Oftentimes, data can be uploaded immediately after the collection, giving reviewers that precious extra time to view, review, sort, and filter that data. I'd like to end with some key takeaways from today's presentation. Digital forensic acquisitions can provide data from a wide range of digital devices. Best practices are a must and should always be followed. The types of forensic images are physical, logical, and targeted for computers and hard drives. So much information can be uncovered from the forensic examination or analysis. Hash values are very crucial, basically the fingerprint of the file. And metadata is data about data, one of my favorite sayings. If a file is deleted, it doesn't always mean it's gone. And finally, the relationship between forensic and e-discovery can be very beneficial and substantially increase success within an investigation. I'd like to thank you all for your time today. Pass it back to Jeff with more information.
Thanks, Nick. That was a fascinating presentation. So I'm going to briefly walk you through how Lexby helps boutique firms address the issues of e-discovery in a COVID world. One of the great aspects of the time that we live in is that there is absolutely no need to have large, expensive in-house technology infrastructure for e-discovery. Broadband is almost ubiquitous, and the cloud not only delivers massive computing and storage capabilities for a fraction of the price, but it is also highly secure. With Lexby's cloud-based e-discovery platform hosted at Amazon Web Services, you get on-demand capabilities that equip you with superior technology that hyperscales on demand when you need it without the huge expense of dedicated technology and big law infrastructure. The cloud more than levels the playing field for boutique firms handling document-intensive cases. With Lexby's cloud infrastructure, you can get from document ingestion to review faster, and you get your productions out the door faster. You can enable all of your mobile connected employees that are working from home to access the Lexby e-discovery platform to work on their matters and not miss a beat during the COVID pandemic. On this slide, I wanted to point out that Lexby is truly end-to-end e-discovery in a single cloud-based platform. We engineered our own processing engine, and most e-discovery platforms don't have a processing engine fully integrated. So with other solutions, you've got to move data around from one platform to another. With Lexby, it's fully integrated. So you don't have to use another party to get that done. In addition, we have AI-powered analytics and TAR that a lot of e-discovery companies outsource to another third party, but not us. We deliver a seamless and highly efficient experience. Now I'm going to talk to you about the Lexby Uber Index. When we process documents, we extract the native characters and the metadata. We generate a normalized PDF and perform optical character recognition, or OCR, and extract those characters. We also OCR all images and incorporate translated characters into a single concatenated, what we call Uber Index, which is lightning fast. You can also seamlessly add documents without having to re-index the entire data set, unlike many other e-discovery solutions. One of our clients the other day told us that they had transitioned to us from another e-discovery provider because it took over 48 hours for them to gain access to their matter again because they had to re-index when they added documents to a particular case. With Lexby, you won't have that kind of downtime when you add documents to your matter. Lexby transcription, I wanted to touch on this briefly. Certainly with the growth of Zoom calls and other web conferencing services, we're seeing a lot more recordings in matters. And with Lexby's transcription capabilities, you can easily incorporate these files into your review workflow. Our artificial intelligence engine will go through the transcription process and identify speaker 1, speaker 2, speaker 3, and also help you understand exactly where on the audio track the evidence resides. So it makes it very simple and seamless to manage. Lexby AI. So artificial intelligence, it's a term that's thrown around a lot. And here you'll see applications of artificial intelligence within the Lexby Discovery platform. Our advanced AI capabilities deliver really high quality results, including transcription, translation, sentiment analysis, cognitive image recognition, entity identification, and more. So we utilize a wide range of AI algorithms that perform a bunch of complex tasks and help you get through your review faster. And those are included in the eDiscovery platform and fully integrated, and again, not from a third party. Now, a little bit about Lexby pricing. I'm going to share with you an example of our best-in-class pricing versus a competitive bid that one of our customers received. We've purpose-built the Lexby eDiscovery platform to take full advantage of the incredible efficiencies that the cloud has to offer, and we pass those savings on to you. With Lexby, you don't pay for processing versus what you can see here. Relativity Reseller was charging $125 per gig for processing. So with Lexby, you pay $0 for processing. With Lexby, you pay $0 for user fees. You can have unlimited users in the Lexby eDiscovery platform, and it won't cost you anything more. With Relativity, with this particular reseller, they're charging $95 per user per month. That's a monthly recurring charge that you would incur. And then for technology assisted review, near duplication, or email threading, you don't have to pay the $30 per gig premium that you do with Relativity in this case. With Lexby, that's included in the Lexby eDiscovery platform in your monthly hosting subscription fee. And here, the Relativity reseller was selling hosting at $8 per gig per month. With Lexby, it's $5 per gig per month. So with Lexby, you don't pay for processing, you don't pay for user fees, you don't pay for advanced analytics. You simply pay $5 per gig per month for a hosting subscription starting at 50 gigs. This was an example of pricing that one of our clients received from a Relativity reseller, and we saved our client thousands and thousands of dollars on this particular matter. So if you're paying more than $5 per gig per month for eDiscovery, then you're missing out on the great efficiencies the cloud has to offer. And with that, I'll ask our last polling question, and that is, would you like a demo of the Lexby eDiscovery platform? Thank you for attending today's session. We'll be making the following available to webinar attendees. You'll receive a recorded streaming version, an MP3 podcast, as well as PDF slides. Please let us know if you have any questions or comments about this webinar or suggestions for future topics. This webinar is part of the Lexby eDiscovery webinar series. For notices of future live and on-demand events, as part of this series, please email us at webinars@lexby.com or follow us on LinkedIn. And I'd also like to thank Nick again for his presentation today. It was fantastic. And I thank all of you for attending. Please watch your inbox for an invite to our next webinar on best practices in eDiscovery. Take care.